Oh God, no, cycle crossway.
Okay.
I don't trust myself on the motorcycle. Far too much ADD for that. All right, can you see that okay? I think that's okay. So let me explain to you what the hell you're looking at here. Blue curve and a red curve. It's similar to your key experiment, except I'm letting Excel pick the keys. That's the difference. The difference is Excel is going to randomly select keys. Every time there's an F9 button on your keyboard. You probably have never used it before. You're going to use it a lot in this class. I like the F9 button. The F9 is called a reload button. It's kind of like pressing the little curly arrow thing on an Internet Explorer webpage to reload it. Same thing. It reloads any command in an Excel spreadsheet that's called dynamic. In this case, let me show you. We record. Yeah, we're good. So I want to show you. There's a bunch of data you can't see because it detracts from looking at the graph. All in here, there are random numbers being generated. There's one of them right there. If you look up in that formula bar, top left corner, square root, root, negative, natural log, rand. Those rand commands that are up there are random numbers being generated by Excel. So in other words, in some ways, you guys were a random number walking in here on Tuesday with your keys. I mean, I had no idea how many keys you had with you, and you probably didn't think about it at all. So there's some randomness in how many keys you have in your pocket. Ish. I mean, you have a car, and you have a house that you have to unlock. You might have a bike you have to unlock, or a P.O. box you have to unlock. So there's some stuff is determined, but how many keys for your house? That's somewhat random. If you're renting a place and you rent a new place, maybe the new place has a garage separate from the house, so it's got 2 keys versus 1. So there's a little bit of randomness going on. So I took it to the logical extreme, which is everything is random. Everything is random. And I said the least number of keys you can have is 0, and the most number of keys you can have is 20, just to kind of span the gap of what I've seen in this course. I actually had one, I don't think I showed you guys, I'll show you the graph. I've kept track of keys over the past 10 years. All the key data you guys give me, I put into one graph. I'll show you that one day I had to keep like 19 keys or something. So I tried to like to span the graph. The blue chart in the front, it looks like group data because it's a histogram, but technically speaking, it's a box plot, isn't it? Technically speaking, it's a box plot because look at the width of each of the bars. 0, 1, 2, 3, 4, 5. They're not grouped. So literally, there are 170 tens. There are 148 nines, 105 eights. There's no question as to how many of each data point there are, because they are that. Does that make sense? So even though it's a histogram, it's kind of a cheaty, it's a dot plot. Let's not call it a cheaty, it's called a dot plot, without the dots, because that's exactly what it is. Fair? I like those. Very often I like those, because you get the visualness of a histogram, but you also get the exactness of raw data. And whenever we can do it, we're going to use those whenever we can. You can't all the time. Very often what you get is you get this red thing behind it, and the red thing behind it is the exact same data, but it's grouped. So it's grouped in widths of 3. So that first bar back there that says 0 is how many 0s, 1s, and 2s are there. Well, if you can see it, you can probably see it better than me being further away. They're all 0s right now. So 0 plus 0 plus 0 is 0. Done. The next bar is going to be the sum of 3, 4, and 5. 4 plus 9 plus 17 is 30. And then it's going to be 6, 7, 8. 48 plus 66 plus 105 is 219. So with the red bars, what you're getting is the sum of those 3 categories. Now every time I press the F9 button, you're going to get 1,000, or I think there's about 1,000. Yeah, there's 1,000 data points. There's a new set. 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 And so forth and so on and so forth and so on and so forth. So I can hold down the F9 button and it just, oop, it's a little slow in this classroom. I can't just hold the F9 button. I keep pressing it one at a time. Okay.
Well, this doesn't change very often. Like, it doesn't change like a bunch. Sarah.
Sorry to do the Darth Vader on you there. Apologies. Did you hear what Sarah, okay. Did you hear what Sarah said? She said, at least they're not changing all that much. How dare that? How is it not changing all that much? That's the part that makes this called the law of large numbers. Can't prove why it does or why it doesn't. Other than the fact that I've made them be bell-shaped. Oh, I call this uniform. Uniform, it's not uniform, no, it's bell-shaped. Never mind, ignore that word. It's irrelevant. I had to put a function in. I had to put a formula in to generate the data. And I'm going to make this spreadsheet better when I have more time by putting different formulas in. but just do the exact same thing. They're not going to deviate. They do deviate, yes? They deviate. Right now, we actually had somebody with 2 keys, yeah? But we had nobody with 2 keys before. And then we have 3, 7, and 17 here. That was different the first time, wasn't it? So there is deviation, but it never deviates too far from what it is at any given time. Much like your key data doesn't deviate very far from historical anecdotal data, which we'll come back to. So ready to go?
Okay, so I had a thought in my head.
Good.
It's probably gonna mess you up, but
No.
I just wanna try to check this out.
Too late for that, my friend.
Okay, so I think what happens, right, so we had let's say 2 class sample groups. Our sample size would have been 1,063 classes.
Good.
Even though it would have been groups of X's and O's that would
Sure.
have been 6 or 8 long, the average, or the mean would have averaged out. Is that what?
You're seeing it in this. And that's, no, what you're saying is exactly correct. So check this out. Using that idea, if I go into, say, this 27 bar right here, but that 27 is the frequency. It spans 3 to 5. Now, we're not going to see this blue distribution if we're given the red one. You're either given the blue one or you're given the red. You're not given one. You're not given both. So, from 3 to 5, what are we going to call that category? 4. We're going to call it 4. But the problem with that is, if you look at the blue one, you're not going to see this in the world because it's hidden from you. But if you do look at the blue one right now, there's only 7 out of 27 4s. Yeah? There's actually way more 5s than 4s and 3s. Which means calling that 4 means we have done what? We've underestimated the value of those data points, haven't we? Go over one more. Go to 5, 6, 7, and 8. Uh-oh. We're going to call those 7, aren't we? Crap. But the problem is there's more 8s than 7s and 6s on average. So once again, I'm nervous. But then I stopped being nervous because... Why doesn't it matter? Sarah?
Catch on the downside.
Look over here at 15, 16, and 17, which is the symmetric opposite of the 3, 4, and the 5. You see what happened? We're overestimating here and underestimating here, which cancels out. And there's only one that doesn't do that, and it's the middle bar. The middle bar is the only one. 9, 10, and 11 doesn't do that. But that doesn't matter anyway, because it balances itself. Because 10's in the middle, and 10 is the average of this. Did you catch that up there? The raw data average versus the group data. Watch this as I hold that F9. Look what's happening with the average of the group data versus the average of the raw data.
Around 10.
Up or down?
It's hovering right around 10. It does go up and down from 10 though, doesn't it?
No.
But the question is, how much does it go up and down from 10? Not much. Check it out. Look at those numbers going by. What's the smallest we get? I saw 9.7 right then.
Yeah.
Nothing less than 9, nothing more.
9.9. So I did see a 9.7 come through. 9.9, 9.9, 9.9.
So 9.5 to a little over 10.
Yeah, and we're not even getting really down even 9.5. It's like the 9.7 to like 10.3 maybe. That range, FYI, is predictable. And part of what we're going to study starting Tuesday is how to predict that range. How far out can you predict it's going to be most of the time? It's part of class. I mean, you know, how far can you bend that arm in rehab before serious pain occurs? You should know that before you snap somebody's arm off or break it even worse. So it's predictable based on data. I actually got some great data last night I'm going to share with you guys in a couple of weeks. I have to put it together in a more meaningful way. But involving a cable bill, or actually a data transfer bill from Ben Broadband. Being able to extrapolate acceptable data ranges from a certain number of data points, like we're doing right now. It's all tied back to this class. Freaking rad! But the point right now is, how much different is the raw data average and the group data average? Go!
Okay, so is this the same thing, like if it varies, it has a 4% variance, it has no variance? Does it count for that too or no?
That cannot be easily answered. You can't answer that with a yes or a no. It depends contextually.
Okay.
So what Serenity is asking, I'm going to say it now, we're going to talk about it throughout this course. Margins of error. She's talking about what's called a margin of error, which some of you have probably heard of. I would hope that everyone has heard of this as an American, but the fact of the matter is the news media horribly underrepresents it. If you have a 4% variance or a 4% margin of error, very often you'll hear things like, we'll give a little sidetracked here, but it's okay. I think it's a good thing. Obama, approval rating, fell below 40% for the first time since last month. Now it's 39%. That's what a Gallup poll would say, for example. Gallup poll. What the hell? Let's pull a Gallup poll up. See what Gallup says about Obama's approval rating. This is a perfect example, actually, Serenity. Gallup. Gallup, approval. There we go. Let's see how he's doing. 3-day rolling average, good stuff. Can I make this bigger? Okay. Margin of error on this poll is 3 percentage points. Okay, see it down there? I'm going to train you guys to look for this very, very thoroughly in this course. So what you're seeing in this graph is a squiggly. The green is the percent approval. Dark green, I guess, is the percent disapprove. So what you have to do is you have to look at that percent approval with the margin of error. We've discussed that already. So for example, back in February of 2009, I'm fairly sure that a higher percentage of Americans approved than disapproved of Obama. Because even if I slap 3% on these numbers, they're still really, really far apart from each other. It's when it gets in here that nothing is meaningful. See, right now, it's at 53-39. That's meaningful, isn't it? Because 53 minus 3 is 50. 39 plus 3 is 42. There's at least an 8 percentage point difference between those two things, yeah? There's at least an 8 percentage point difference, which means I can tell a difference. I can't tell a difference when it starts getting back like this, and Gallup actually allows you to just do the slider, which is actually kind of tricky. It allows you to slide back to a certain point in time, right? Oh, they don't give you the percentages though. Bastards. Well, right about there. Oh, what are they doing? They're really zooming in? No, they're not zooming in. What the hell is going on? Is it zooming in?
Yeah.
Oh, it's cutting the, no? Yes, it's cutting the tail end of the graph off. Okay, so they go back like here. Okay, yeah, that's when there was definitely a difference, clear difference between approve and disapprove. It's basically cutting off everything that's gray. So if you get in super close to one of these areas where there's a close intersection, like right about there, all of a sudden you start realizing, oh, here we go, mouse pointer above, that works great. So there's a meaningless difference right there. Well, actually, yeah, that's arguably, because 3 percentage points down from 50 is 47 and up from 44 is 47. That gets confusing as to what we should call that. That's the best answer to your question is, it depends on what you're comparing.
But so we can use it for all statistics.
Yes, you can, but I can't always say it's meaningful or not meaningful. Let's look at the entire picture.
Okay.
Is that fair? Great question. And it's a little more convoluted here than it is in our little random number document that we're looking at right now.
Okay.
But it will become less convoluted as we learn more in the course.
And so that 4% just strictly related to what we were talking about before, because this is a 3% margin of error, so our margin of error depends on our
Sample size.
Okay.
It depends on sample size, something called confidence, and we'll get into all that. That's something part of the course too. Yeah, you're about a course ahead of us actually. It's okay though. It's okay. There's little bits and pieces we're picking up as we go. One of them is variance, which we haven't even really talked about. We're talking about center still. Center. You guys look like you need a break. Yeah. Let's take 5. That heater is pumping, isn't it? Oh, crap. We're going to crack that door. Maybe open the window just to piss everybody off. I think somebody else opened the window, which is why the heater came on. Apparently this building is...